Hey everybody, in this lesson I'm going to be talking about what is Arduino and just giving you a basic overview. So to start, let's meet the Arduino Uno. So with your robots you should have received an Arduino with a motor shield on top of it, but if you took off that motor shield what you would find is a board that looks just like this. And at the core, the Arduino is just a microcontroller. What's a microcontroller? Well, it's kind of like a tiny computer. And they're used everywhere. Your phone has them, your microwave has them, your car has them, like everything. It's not the only one. There's a lot of other kinds. Arduino is just built off of a really popular chip. So there's a lot of support, big community around Arduino, and that's why we chose to use it. So really versatile, but the barrier to entry is pretty low. So the Arduino does three really core things. First of all, it can sense things. It can take in inputs. And it does this through a few different ways that we'll talk about in a little bit. But what matters is that the program has some way of gathering information about the world around it, usually done through sensors. And in fact, almost always done through sensors. But it has a way to take in those inputs. So next, it can run logic and it can think about those inputs. So based off those inputs, it can make certain decisions and do certain things. These are, of course, things that you have to program and you have to tell it to do, but it is capable of doing them. And lastly, it can make outputs. So these outputs allow our robot to act, to do things like move or flash a light or make sounds. So let's talk about how to interface with it. With Arduino, you work with it using pins, and pins are these little black strips along the side. You can plug wires into those. So there's a few different kinds of pins that we're going to talk about. So yeah, here's all the pins. There's three main kinds. There are power pins, like this power jack that you plug in the battery pack to. There are digital pins, like the ones alongside here, and some of these. There are analog pins, which are these. And then, yeah, there's also more power pins, which are along this rail right here. And there's a few other things that this does. So let's talk about that a little bit more in detail. So let's talk about the power pins. So if you look, there's this 5-volt pin right here. And if you notice on this board, and on your boards too, there are these little writings, and they tell you exactly what that pin does. So A0 right here connects to that pin. Yeah, so 5 volt, it takes in exactly 5 volts, so really don't put anything too much above or below that, otherwise the Arduino either is going to lose power or burn out in certain ways. Definitely don't plug in ground to that. That'd be really bad. 5 volt is really useful for when we're powering sensors. A lot of the sensors we use have their own kind of tiny microcontrollers on them that help them make sense of the data they gather before sending it to the Arduino. And so we've got to power those off of 5 volts. So oftentimes we'll be plugging into that 5 volt pin to power our sensors. There's also the ground pin. There's 2 of them. This is for ground, 0 volts. Don't plug anything else into it, otherwise you might short it. Oftentimes our sensors, if they're going to need a 5 volt, they're also going to need ground so they can have power. So basically when you're powering something you need to have a positive and a 0 voltage, and you'll get that from the ground right here. There's also a pin that says 9V. It's also called VN on a lot of others. This is basically the raw power that's coming into it from the power port. So in our robots particularly, we're plugging in 12 volts into this power port, and it's got a linear regulator, this thing right here, that's dropping that power down to 5 volts, because the Arduino, it uses a 5 volt logic level. So that means all of the kind of thinking that it's doing, all of the communication through the pins, it's done at 5 volts. So you've got to take your power in and convert it down to 5 volts. So this is just a way to access that power in. I'd be really careful about using this pin with different things. It's definitely easy to burn out sensors if you use that, because that power is really only good for our motors and just straight inputting. Yeah. So let's talk about the digital pins. It's the green ones right along here. You'll see the 0 through 13, I guess. So digital pins can be used as an input, and the inputs they're receiving are either 0 or 1. And what it decides is 0 is anything that's a ground or 0 voltage, and that will read as low. And anything that's like 5 volts will read as high, and sometimes there's a little bit of in between. So yeah, an example of this is if you're going to use a push button. When a pin is not seeing, if you connect a push button to a pin, and you also connect the push button to power and ground, whenever the button is not pushed, it'll read it as low, but whenever it's pushed, it'll connect it to high, and it will read it as high. It can also be used as an output in the same fashion, so you can either output 5 volts or 0 volts if it's low. And you can decide in the program how to do that. There's also another type of thing you can do with it. It's called serial communication. This is actually how our board communicates with our computer. This USB port is connected to this 0 and 1 pin. It's called RX and TX. I would strongly advise avoiding using pins 0 and 1 just kind of when you're doing stuff with it, because you're going to get some funky things, especially when you're uploading your code or it's printing things. So definitely try to avoid these if you can. And you can also create software serial. So if you want to communicate with another board, there's libraries that let you do that with pins that are not just 0 and 1. So analog pins, they're the blue ones down here. In a similar way to digital pins, they can take in inputs, and they can actually act as digital pins. But with analog pins, you can do what's called analog read, which means you can read in a value that's between 0 or 5 volts, and it's a different voltage, and you could distinguish that value. So there's a few different things that use this. For example, like a potentiometer would use this. It's in a joystick, and it can just tell you the position of that potentiometer. And yeah, you can use it as a digital pin, and you can also make outputs. So there's a few different ways to power our Arduino. The first of which is through the USB cable. You'll notice that when you are plugging in your robot and uploading code, the power light comes on. That's because the USB cable is supplying power as well as data. Now be careful with this, because sometimes the Arduino can draw more current than your computer's USB port can provide, and sometimes it'll cause it to heat up or not work, or it'll reset the connection. You'll have a hard time uploading. So whenever you are uploading code to your robot, I would suggest turning your robot on if you're having issues connecting, because that will allow you to, that will basically give the robot the current that it needs, so it's not just pulling it from your laptop. I would also note, if there's a short on your robot, meaning if 5 volt and 0 volt are connected, ground and 5 volt are connected, it will shut off. Your computer will detect this and shut off the port, and it'll make it a pain to get started again. So really avoid plugging in anything that's shorted to your computer. You'll also have the power port. This is also called a barrel jack connector. This is what we plug in our battery to. This needs to be between 6.5 and 12 volts. If you put in anything lower than 6.5 volts, the Arduino's linear regulator, which brings the power voltage from the higher voltage down to the 5 volt lower voltage that it needs, it requires at least 6.5, because it's not always optimally efficient. So there's some loss of voltage when converting it, and it just so happens that anything below 6.5, when it converts, that actually ends up being a little bit lower than 5 volts, and that's just not what we want. Lastly, you can also use the power pins. You can plug into 5 volt and VN. These, like the VN pin, is directly connected to the barrel jack, so they're essentially the same, just depends on how you want to deliver it. When it comes to running code on the Arduino has some code uploaded to it right out the back. So when you turn it on, every time you turn it on, it will run your code again. So it's just like starting it over. And when you first get your Arduino, there's not really any code uploaded to it. I mean, there technically is, but it's not something that does anything, so you won't know it. But yeah, so if you turn your robot off and then back on, it'll start the program over again. If you hit the reset button, there's a little reset button next to the USB input on the motor shield that we use. If you hit that, it'll just start the code over again. And lastly, when you open the serial monitor while it's plugged in your computer, so there's a serial monitor inside of Arduino Create and the offline IDE that lets you kind of talk to the Arduino, and it makes it easy to debug. If you open that, it'll send a signal and start the program over again, so you can debug it easier. When it comes to actually getting code on the Arduino, there's two main ways. The first is using Arduino Create Online. This is what we primarily use, simply because it manages including the libraries really easily. So you'll notice right here it says include Moorebot. This allows you to use the Moorebot functions. On the offline editor, it doesn't automatically pull that library. With the online one, it does. It also makes it really easy because I can give you a link to my code, and you'll be looking at the same code that I was using. It does have some disadvantages. So, for example, it does not. Well, it requires an internet connection, They limit how much you can compile a day. And you do have to have a browser plugin. So there's some browsers that work and some that don't. I know Google Chrome works. This is also the only way to make it work if you have a Chromebook. Chromebooks don't work with the offline editor, unfortunately, and you do have to pay for that. So the other option is the Arduino IDE, which has been the traditional way to do it. Arduino creates relatively new. The offline editor, they've got downloads for Linux, Windows, Mac, you name it. It's tried and true, it works, you don't require the internet. You do have to download your own libraries for the most part, which is slightly more difficult, but overall not too bad. There's a lot of different boards that work with the Arduino IDE. That's one of the things that's really cool about Arduino. So if you get comfortable with using these tools and you keep playing around with this kind of stuff, it gives you some kind of familiarity when you start to work with other things. As far as going further, this is meant to be just a really shallow overview tutorial, but there are things like the Arduino forums that are really helpful if you get stuck on something. A lot of people have worked with Arduino, so if you have a question, odds are somebody has asked that and had that same question before too, and somebody's given them an answer. So start by Googling and looking at the forums. And Arduino has a ton of free tutorials that you can explore. And if you go to the Arduino editor, there are these examples. And they'll show you a lot of really cool stuff that you can do. Like the basics, you can go to Blink, and this is a really popular program that you can get started with that just blinks the LED on your Arduino. But there's a ton of resources. Basically, as long as you're just Googling and seeking this stuff out, you'll have no problem finding it. And of course, you can always email us or ask on our forum if you have any questions. So good luck, have fun with your Arduino.